What is my biggest disappointment in the history of space exploration? Will the YR4 asteroid have a chance to hit the moon? Does the Solar Gravitational Lens need a coronagraph? And in our free extended version, how time dilation changes intergalactic travel. All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I'll answer them here. All right, let's get into the questions. Jeremy Robinson, Solar Gravitational Lens question. Will it need a coronagraph for the sun? What about the glare from the target star obscuring planets? How are we going to see continents if they are bathed in warped starlight? In the past, we made the joke that all the questions were about the Lagrange points, but now I think all of our questions are about the Solar Gravitational Lens. And so I think, we have room in our hearts for both. So the question you're asking is, one, will you need a coronagraph when you're using the Solar Gravitational Lens? And for those of you who are still getting up to speed, the Solar Gravitational Lens is that if you go about 550 astronomical units away from the sun or farther, then you can use the gravity of the sun as a natural telescope lens that then gives you many orders of magnitude more magnification of this thing that you're trying to do. It will allow you to see a 1 megapixel image of a Earth-sized world orbiting around a star tens of light years away from us. But that's what's theoretically possible. What would it practically look like? Well, you have the sun that is out there now, 550 astronomical units. The sun is going to look like any other star, like a slightly brighter star than everything else that's out there. But it won't be this giant disk. You will want to block the light of the star, but it's a very easy task to do because we know the shape of the sun. It's not that complicated. And the thing that you're looking for is in this ring that is around the sun. It is this warped sort of circle, like an Einstein ring that's going to be around the sun. And when you're concerned about like the warping of that thing, absolutely. But because we know the exact shape of the sun, then you can reconstruct the original object. If you know the shape of the lens, then you can reconstruct the thing that's being lensed. The problem with gravitational lenses is they are these blobs, these galaxy cluster blobs out there that contain, tens of galaxies and the dark matter that's around it in this really irregular shape. And because you don't know the shape of that blob, you can't reconstruct the thing that's being lensed. But with the sun is this sphere. We know it's how flattened it is as a sphere perfectly. And so you can use that to then reconstruct to see the shape of the planet that's being lensed. Will you see the star? Well, no, because you're lining up the gravitational lens with the planet. Now the planet is going to be going around the star, and so there's going to be times when you can see it and times when you can't. But you're not looking at the star, you're looking at the planet, and that matters. That much of a change in orientation. You don't even need a big telescope. And so the nice thing about the Solar Gravitational Lens is that it removes all of the problems that you get with other kinds of astronomy because you set it up perfectly. The challenge is to get out to that 550 astronomical units, to get there in a reasonable amount of time. That's much farther than the Voyagers have gone in 50 years. So we have to have a way to get out there relatively quickly. Mark Luoma, I read that the asteroid heading near Earth could hit the moon. Do you have any comments on that? I concur that astronomers have reported that the asteroid 2024 YR4, that originally they had estimated there was going to be a 1% chance, a 2% chance, a 3.4% chance of hitting the Earth in 2032, has now been scaled back down to a 0.001% chance of hitting the Earth. But the chance of hitting the moon has remained relatively high in that it has a 1% chance of hitting the moon when it passes through the Earth-Moon system. And I would not be too certain that that 1% is a really rigorous, accurate number. The moon is a much smaller target than the Earth is. And so you've got to get the this asteroid coming in exactly the perfect way that it's going to hit the moon. And with more observations, years of observations, astronomers will nail down the orbit of the asteroid to the point that they know whether or not it's going to hit the moon. So right now, it's not like it's probably going to hit the moon. There's a estimated 1% chance of it hitting the moon. And even like the attention on this asteroid is off now that we know that it's not going to hit the Earth. What I'm anticipating is that they will scale it back down and has a 0% chance of hitting either the Earth or the moon. And even if it did hit the moon, it would be pretty insignificant. It is a 40-meter asteroid. That is not big. It would make a little flash on the moon. We would see it. It'd be cool. But it wouldn't rain rocks down on Earth like Seven Eves. Casey Ream. On the Kardashev scale, is it true that the Fermi paradox rules out the existence of any type 3 civilizations? What is the most advanced civilization on the scale that we could possibly miss? It's a really interesting question. All right, so for people who kind of don't understand the Kardashev scale, right? Type 1 is a civilization that's using all the energy that falls on its planet. Type 2 is a civilization that's using all of the energy coming from its star. And Type 3 is a civilization that is using all of the energy in its entire galaxy. And the form that that takes is probably some kind of Dyson sphere, right? Or a Dyson swarm, where you are enclosing your star in a swarm of satellites and they're collecting all of the sunlight that's coming from the star and then you're putting it to some kind of productive use. And that, you know, when we look out into the universe, when we do these giant surveys of other galaxies, what they look like is just galaxies. They don't look like galaxies where half of the stars in that galaxy have been surrounded by Dyson swarms, because they would no longer be shining in the visible spectrum. They'd be shining in the infrared. And so you would see this very weird galaxy that has spiral arms and looks exactly like a normal galaxy, but it's all infrared. Or you would see it half complete. And we don't see that. In fact, you know, many comprehensive surveys have been done looking out into the universe, trying to find galaxies that have been turned into these advanced civilizations, and we don't see that. And you would think, like, if there was like some futuristic robotic civilization that was gathering up all the stars in the galaxy, and maybe they were moving to other galaxies, because that's possible, that you would see the sphere of galaxies where within the sphere, they've all been Dysoned, where they're all infrared. And then outside of that is wilderness, galaxies that have not yet been Dysoned. And so that is the kind of thing that would be very obvious. And so if that was happening out there in the universe and we were pointing our telescopes out, we would see it, and we don't see it. What it looks like is just raw galactic wilderness. But if there were civilizations here in the galaxy that were doing the same process, they were beginning their, turning the entire Milky Way into Dyson spheres, then we would see a sphere of Dyson spheres inside the Milky Way, stars that are like a point source of infrared radiation. And astronomers have done some surveys of stars in the galaxy. And so far, they found some interesting candidates, but those interesting candidates could also be explained by a really far away quasar that's enshrouded by dust and giving off a very similar infrared signature. And so none of these are slam dunks. But that is the kind of thing that we should be able to see. Again, if you think about the space exploration games where you're building a galactic empire like Stellaris, right? We would see regions of the Milky Way that were in infrared. Like you could go out with your own eyes and you would look up into the sky and there would be these holes where there should be stars and you don't see stars because they're all being turned into infrared surrounded by Dyson spheres. And we don't see that. And so like people have done surveys and none of this shows up. So we know that there are no civilizations that are gobbling up vast galaxy clusters. We know that there are no civilizations within the Milky Way that are gobbling up the Milky Way. Any civilizations that are here with us in this galaxy have got to be either right at the very same stage that we are, or are better at hiding what they're up to. We should be able to see them, and we don't see them. If you want even more questions, you should join our Patreon, where me and my producer Anton record a very long patrons podcast questions special where we answer all the questions that came in this month from all of the patrons. And the show just keeps getting longer and longer. I'm sure it's going to be above 5-6 hours for the next episode. So you can go and find that at patreon.com/universe today. And thanks to everyone who's already subscribed, and welcome to our recent newcomers: Seth Ambrose, Adam Levine, Michelle L., Stephen Bailey, Armin Walland, and John Majorczak. Join our amazing community at patreon.com/universetoday. Luke Q. What is the current biggest disappointment in space exploration? So I would say the biggest disappointment in recent memory is the loss of the Kepler spacecraft. So, the big question that we always have is, are there any other Earth-sized worlds orbiting around sun-like stars? And we don't know if there are any other Earths out there, but back in the mid-2000s, NASA launched a spacecraft that's job was to answer that question. It was going to stare at one chunk of the sky for a very long time, and then it was going to just watch all of the stars and see if any were having transits, planets passing in front of them. And it was so sensitive that it would have been able to detect an Earth-sized world passing in front of a sun-like star. And it was going to stare at this spot in the sky for so long that it would have detected, one transit, and then around 365 days later, another transit, and then about 365 days later, another transit. You get 3 of those, passes by a planet that is about the size of the Earth passing in front of a sun-like star, and you found another Earth. And it's within the habitable zone of that star. And so it was expected that Kepler would have found these planets. And unfortunately, a couple of years into its mission, before it could make these confirming observations, its reaction wheels died. And it could no longer point directly at the targets that it wanted to with the level of precision so that it could track those movements. And so they had to change the plan with the spacecraft. And like how they did it is incredible. They essentially used the light pressure coming from the sun as a force on the telescope. And then they were able to use the reaction wheel that they had remaining to balance against that force from the sun. And they were able to watch and detect planets orbiting around red dwarf stars. But that was the consolation prize. We lost the real prize, which was that it should have been able to find that other Earth. And if Kepler's reaction wheels hadn't failed, then today we would be talking about all of these really interesting Earth analogs that are out there. We would know of 5 or 6 or maybe 10. Who knows how long Kepler would have kept going, would still be going. Maybe like now would have run out of fuel, but we would know of a handful of other Earths that would become the primary targets that all of James Webb and all of these other telescopes would be focusing on and helping us learn more about it. But because Kepler wasn't able to complete its mission, we don't know. And that sort of delivery of information never arrived. And there's no spacecraft right now that can do this. No one is planning. Maybe the upcoming Plato spacecraft is going to be able to find this. Maybe TESS could find this, but TESS is a very small spacecraft compared to Kepler. And so now astronomers are planning to build the Habitable Worlds Observatory, which is a telescope designed to observe Earth-sized worlds orbiting around sun-like stars. But if you don't have targets for it, where do you point it? And so it's going to have to spend a lot of time just finding those worlds in the first place before it can even start observing them. So I would say that is my greatest disappointment, is the loss of the Kepler spacecraft. Darth X0, what does the privatization of space mean for us? Or you said we? Us? I'm like, and this is like something different, but are you talking about us? We are already deeply into the privatization of space. There are thousands of satellites that are orbiting around the Earth that are doing all kinds of activity, from weather monitoring to communications to science, to command and control of militaries, and more are being launched all the time. And so the rockets that launch the satellites are private companies. The satellites themselves are built by private companies, and then the satellites are operated by private companies. So that is the privatization of space. And yet there will always be the bleeding edge of this. There will always be the unknowns, the technical challenges that no company is willing to take on, new kinds of propulsion systems, new kinds of materials that will require an investment that a company can't make. And so you're always going to get this balance between technologies that have been figured out and they have been privatized, as well as the technologies that have not been figured out, and only research funded by governments really can support that kind of development. And so those do go hand in hand. Like, it doesn't make sense for a government to build technologies that are well understood, like, I don't know, televisions, cars. But it doesn't make sense for a company to invent an entirely new kind of nuclear rocket engine so that they can explore the solar system. So, I think where we get into difficulty is when government agencies take on the kinds of things that are well handled by the commercial sector. And then at the same time that you get governments that don't appreciate that basic research is really important, that all of the wonder that we have today, the internet, the kinds of technology, the fact that I can play on my Steam Deck, the fact that we can launch rockets, like these are all the result of basic research that somebody went out and said, I wonder how this works. Not, I can make a technology that will exploit this mechanism. It's like, just what is it? How does it work? What's beyond that, over that mountain? Where do stars come from? Where do planets come from? What happens if you mix these kinds of chemicals together? We don't know the outcome. That's basic research. And there is no commercial viable way to be able to do basic research. It has to be done by governments or patrons. So there's always going to be this balance between the two. And sometimes the emphasis is too far one way, and sometimes the emphasis is too far the other way. And sometimes people make cuts to basic research when they shouldn't. And other times people fund basic research that is in a dead end. And yet here we are in this modern, advanced technological civilization, the end result of thousands of years of people continuing to ask questions about the very basic nature of reality. Did you know you can watch the same video with no ads and get a bonus question over on Patreon completely for free? And this week's bonus question is all about how time dilation would change intergalactic travel. And I'll put a link in the show notes. All right. Those are the questions that we had this week. Thank you everyone for watching. Now, of course, we do this show live every Monday, 5 somewhere in the world. So there'll be a link to when the next event is going to be. It's 2 hours long, back and forth with the people who are watching. It's a lot of fun. So definitely check that out. Now, I'm going to give you a bit of an update on what happened last week. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Bear Lake Roofing, Brian Body, Caradwin, Chuck Hawkins, Cy Nelson, David Gilton and David Matz, Dustin Cable, Evan Pro, Greg Feely, Hans Schultz, Hudson Ward, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Lawrence Federico, Michael Purcell, Paul Roebuck, Ren Kaidu, Robeck, Sean Sargent, SpiderSwap.io, Stephen Fowler Melney, Thomas Ilskadron, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So just a quick update. Thank you everyone who responded to the video that we did last week. The response has been overwhelming, and I'm still processing and dealing with both emotionally everyone's response, but also just the amount of work that this has added to us. But it's like the best kind of work where I'm doing all of these interviews with patrons, and we are sort of dealing with sort of all the additional business that's coming in. And the part that's been great, the part that's been really freeing is, and I'm still having to kind of come to grips with this, is that I don't have to think about search engines and algorithms and YouTube and any of that stuff anymore. And so we've been producing a lot of new content on Universe Today this week that is purely based on my whims. So for example, there's the Cycle 4 that's coming out for the James Webb Space Telescope, and I decided that we should do a 5-part deep dive into all of the different science that's going to be coming out from James Webb as part of Cycle 4. And so we've got a couple of episodes about that already, and we've got more coming. The Lunar and Planetary Science Conference happened in Houston last week, and I went through all of the abstracts, all of the meetings that were done, and pulled out about 30 topics that I thought were really interesting and parcel those out to writers. And so we've got like just dozens of stories that are going to be coming out from the LPSC over the next couple of months. You won't see them anywhere else. And this is the kinds of stuff that I'm most interested in. New missions to Mars, missions to Venus, sample return. It's really cool stuff. So thank you for letting me follow my curiosity to the nth degree. All right. We will see you next week.